10th International Physics Olympiad, year 1977, IPHO. I offer private tutoring for Physics Olympiad preparation. I currently have openings. Message me if interested. My email is fred1996@hotmail.com, or you can use Skype name Eduard F. 1996. Problem number 3. An electron gun T emits electrons accelerated by a potential difference U in a vacuum in the direction of the line A as shown in this figure. The target M is placed at a distance d from the electron gun in such a way that the line segment connecting the points T and M and the line A subtends the angle alpha as shown in this figure. Find the magnetic induction B of the uniform magnetic field. Question A. Perpendicular to the plane determined by the line A and the point M. Question B. Parallel to the segment TM. In order that the electrons hit the target M, find first the general solution and then substitute the following values. U equal 1000 volts. Charge of electron E equal 1.60 multiplied by 10 power negative 19 coulomb. Mass of electron Me equal 9.11 multiplied by 10 power negative 31 kilogram. Alpha equals 60 degrees, D equal 5 centimeters, and B less than 0.030 Tesla. Solution for problem number 3. Question A. Find the magnetic induction B of the uniform magnetic field perpendicular to the plane determined by the line A and the point M. Solution. If a uniform magnetic field is perpendicular to the initial direction of motion of an electron beam, the electrons will be deflected by a force that is always perpendicular to the velocity and to the magnetic field. Consequently, the beam will be deflected into a circular trajectory. The origin of the centripetal force is the Lorentz force. So we have EVB equal mv square over r, from which we can find what is the speed v. It will be EBR over m. Geometrical consideration yield that the radius of the trajectory obey a represented figure. So we have radius of a trajectory equal d over 2 sine alpha, and from here we can find that speed v equal EBD over 2m sine alpha. The velocity of electrons can be determined from the relation between the kinetic energy of an electron and the work done on this electron by the electric field of the voltage U inside the gun. So we have 1/2 mv square equal EU, from which we can find that speed v equal square root from 2EU over m. Now we can equalize velocities v from 2 and 3 and find that expression from formula 2 equal to expression from formula 3 for velocities v, like this one, and from which we can find that electromagnetic induction V equal 2 multiplied by square root from 2mu over E multiplying by sine alpha over d. And finally we can put instead of these parameters real numbers. So we have the magnetic induction equal this expression, which is 0.0037 Tesla, and this number is less than 0.03 Tesla. So this is a correct answer for question A. Question B. Find the magnetic induction B of the uniform magnetic field parallel to the segment TM. Solution. If a uniform magnetic field is neither perpendicular nor parallel to the initial direction of motion of an electron beam, the electrons will be deflected into a helical trajectory. Namely, the motion of the electrons will be composed of an uniform motion on a circle in the plane perpendicular to the magnetic field and of an uniform rectilinear motion in the direction of the magnetic field. The component v1 of the initial velocity r, which is perpendicular to the magnetic field, see figure, will manifest itself at the Lorentz force and during the motion will rotate uniformly around the line parallel to the magnetic field. The component v2 rally to the magnetic field with the remaining constant during the motion. It will be the velocity of the uniform rectilinear motion. Magnitudes of the components of the velocities can be expressed as v1 equal v sine alpha, v2 equal v cosine alpha. Denoting by n the number of screws of the helix, we can write for the time of motion of the electrons. From one hand we have total time t equal distance d over v2, which is d over v cosine alpha, and same time t equal 2pr multiplied by number of rotations divided by v1, which is 2prn over v sine alpha. Lorentz force must be equated to the centripetal force. Hence we can calculate the radius of the circular trajectory. So we have EV1b equal mv1 square over r. It means that radius r equal mv1 over eb, or equal mv sine alpha over eb. Now we can equalize both times and get that d over v cosine alpha equal 2pn over v sine alpha multiplied by mv sine alpha over eb. So when we cancel v sine alpha in the right part, we have magnetic induction B equal 2 pi n v cosine alpha multiplied by mass m and divided by dE. And the last thing, we can count speed v from energy equation. So we have 1/2 mv square equal EU. From here we can find that v equal square root from 2EU over m. And finally we will get that magnetic induction B equal 2 pi n cosine alpha over d multiplied by square root from 2mu over e. When we put numbers, we will get that B must be equal n multiplied by 6.7 multiplied by 10 power negative 3 Tesla, which must be less than 0.03 Tesla. So we can just count that the number of possible rotations is 4. And for each number we have different magnetic induction. So for n equal 1 we have B1 equal 6.7 multiplied by 10 power negative 3 Tesla, etc. till 28.8 multiplied by 10 power negative 3 Tesla. That was solution for question B.